This is a geometric question with a little bit of algebra included into it, so it becomes therefore a difficult question and possibly for round 2 or maybe worth leaving. Rhombus has area 12, side A, which is 5, and length of the longer diagonal. So let the diagonals be d1 and d2. So half d1 d2 is the area, which is now 12. So d1 d2 or product of the diagonals is now 24. Second is that I can use Pythagoras theorem in one of the small triangles of the rhombus. So d1 by 2 square plus d2 by 2 square becomes equal to 5 square. So d1 square plus d2 square, or the sum of the squares of the diagonals, becomes 100. Now, either you already know that the diagonals of a rhombus are conjugates of each other, that is, if one is irrational, the other is its conjugate. Or if you look at the options over here and then you look at the equations over here, from there you are able to deduce that, okay, when I am getting a quadratic, for example, when you substitute d1 or d2 into this equation, you will get a quadratic, and the roots of that quadratic are definitely going to be conjugates. From either of these two, you should know. So what will happen is that you will not have to solve the whole quadratic from scratch. So now that I'm looking for conjugates whose product is 24, diagonals which are conjugates whose product is 24, I can now take one option at a time. It's equation 1, that's equation 2. For example, let me take up, so the search for conjugates. Okay, chalo, conjugates, A is missing. So let me multiply this by its conjugate. Root 37 minus root 13 upon 2. That becomes 37 minus 13, that's 24 upon 4, that is 6. Whereas according to equation 1, I need 24. So option A is gone. I try option D because it looks a little easy. Multiply by root 13 minus root 12, that's 13 minus 12, that's 1. But I need 24. So now option C is looking viable. So I'll take option number C for my calculations. Root 37 plus root 13 into root 37 minus root 13 is 37 minus 13, that's 24. Equation 1 has now been satisfied. I'll put these values now for the diagonals into equation number 2 and then square them up. Square plus iska square, which gives me 37 plus 13 plus 2 root 37 root 13. And then plus 37 minus 13, sorry, plus 13 minus 2 root 37 root 13, which will get cancelled out. And this gives me 100. When this gives me 100, equation 2 is also satisfied, and therefore option C becomes the right answer. So we did this in a very, very efficient manner, using our prior knowledge of geometry if you had it, or using your basic concepts of quadratic equations. And this was a nice question.